Welcome back, everybody. We did a previous video where we talked about the rules of a series circuit. Series circuit is the most basic circuit that you're going to deal with on everything. All of the other circuits, the parallel, the combination, all have to be turned into a series circuit for you to find your circuit totals: voltage total, current, resistance, and power. So the previous video was the rules, and now I'm going to show you how to apply those rules. And I'm going to show you some tricks that I know when I went to trade school, nobody said anything about this, and I was doing work I didn't need to do because I didn't know the rules of the game. Okay, so the first thing that I want you guys to understand when you're doing these kind of things, if you're going to take an electrical exam test, and they have questions that are Ohm's law and stuff like that, what you see right here, this is Ohm's law right here. And that's EIR. E, remember, is voltage, R is resistance, and I is your current, okay? So this, as soon as they say go, write that down at the top of your desk, or write it on your piece of scrap paper, okay? Because this is going to be your memory jogger. So here we have the given pieces of information. Now, I will tell you, if out of all this information here, the volts, the current, the resistance, the power, if I get any two of these circuit totals, I can tell you all of the information that's in this, okay? So keep that in mind. For this circuit, the given information is you get 120 volts AC, that's an AC sine wave, okay? Resistor 1 is 25 ohms, resistor 2 is 25 ohms, okay? So this chart right here is what when I was teaching, I would print copies of these things off. The ET is the total, E1, E2, that's the number of resistors. If I had 15 of these, it'd be E1 through 15, okay? And so on and so forth. But the ET, those are your totals inside that circuit, and that's what you got to find to be able to find everything else out. Okay, so when you put this together, the first thing you want to do is you want to write down all the given information that you have. Okay, so right now we know our circuit current voltage is 120 volts, and we know resistor 1 and resistor 2 are 25 ohms. Okay. Now, if you remember, what is the rule for resistance in series? Okay, resistance in series is simply added up. So we've got 25 and 25, so our resistance for our circuit is 50 ohms. Okay, so now we have our two pieces of information for us to find these two pieces of information we're missing. We don't know what the circuit current is, and we don't know what the circuit power is. Right now, I'm not going to worry about the power. We'll come to that because there's Watt's law that falls under also, and we'll get to that. But I want you to know the resistance, the current, and the voltage. Okay, so let's do our math on this. 120 volts, okay, which would be up here, and we want to find our current. So we cover this up. So we got volts divided by our resistance. Okay, so 120 volts divided by 50 is 2.4 amps. Okay. So we have our circuit total is 120 volts. Our circuit current is 2.4, and our circuit resistance is 50. Now, we can check this, and this is one of the key things for you guys to do, especially when you're taking tests or if you're in trade school, you want to figure this out. This number, to me, is a suspect number. Okay, because I did that. I created that through my math. Now what I want to do is I want to check my math. So I can use this suspect number with this number right here, and I can do the opposite. I can do 120. Okay, and we can divide that by our 2.4, and that's going to equal our 50. Now you're going to find some of these numbers, you're going to be a decimal or two underneath, or you'll be a decimal over. That's because, as an example with pi is 3.1415. Depending on how many decimals you take it out, some calculators do 9 decimal points. If you use the pi symbol, it's going to use all 9 and your numbers are not going to come out right. Or I won't say right, but it'll just come out different. If you use just 3.14, well, your numbers are going to be a little bit different, but unless they're significantly off, if they're off by, a 0.05 or a 0.1 or something like that, that's kind of inconsequential, okay? So we can confirm this. We can take 120 and divide it by 2.4. We can take our 2.4 and multiply it by 50, but either way, we can check our work on that, okay? So once we've done that, we've confirmed it. 2.4 amps is what our answer is. And what's the rules? What changes and what stays the same in a series circuit? Okay, does the volt stay the same, or does the current stay the same? All right, the current is what stays the same. So what we're going to do is we're going to automatically bring down our 2.4 because it's already given. It's not going to change unless something else changes in that. But as far as your mathematical problem. So now what we're going to do, if we were to measure this, the current at this resistor and the current at this resistor, they would both be pulling 2.4 amps, all right? So now what we need to do is we need to figure out the voltage drop going across this one, because each one of these resistors are going to consume, because they're equal, they're going to consume half of that 120, okay? So if we take 25 times 2.4, we end up getting 60 on this one. And same thing, because they're both the same, it's going to be 60 on this one. Now the question is, do these add up to this? And it does, okay? So that's a pretty good indication that those are correct, okay? Very simple on that, but just remember all of your resistive loads, they're going to consume. If we had another resistive load here, it would take and divide it. It's just like a pie. The pie is 100, and, let's say it's 120 pieces of pie, and you're going to divide it by 3 people. You're going to divide it by 2 people. There's no more extra pie. And if you have pie left over, then you didn't do your math correctly, okay? Because you have to compensate, or not, excuse me, not compensate, but account for all of the electricity in that circuit, okay? This will come in handy in troubleshooting, because you can do voltage drops across 2 pieces of your part of your circuit, and if your numbers don't come up with your circuit total, you have an extra resistive load somewhere in there, and that could be a bad termination. That could be something that somebody's tied into your circuit and you didn't know about it. They've added a motor contactor or a light or something like that. If it's a light in that, no big deal, but if you don't have any other loads on there, you've got bad connection somewhere, okay? Have any questions with this, give me a holler down below, and stay safe out there. Thank you.